So I've got my game plan. Now I'm just going to execute it. Only after I've come up with a game plan and I know exactly how I'm going to start and finish this proof. So we start with our first given that's listed and follow the plan. I know that because these segments are perpendicular, that implies that angle SUT and angle LUT are right angles. I know that because I know what perpendicular means. So that is definition of perpendicular. From there, I'm just going to keep following my train of thought that I came up with during the brainstorming. I said, well, if both of these are right angles, I know all right angles are congruent. And so that's why the next step printed is that these two angles are congruent. And you would literally write all right angles congruent. It is not the definition of right angle, because the definition of right angle says if an angle's measure is equal to 90 degrees, then it is a right angle. Or the converse of that. If an angle is right, then its measure is equal to 90 degrees. So the definition doesn't say anything about all right angles are congruent. This is just a property of right angles, and you would just have to write that out and tell me that. So this gives me my first fact about these two triangles. Now I'm going to move on to my second given. So I've milked my first given for all that it's worth, and now I'm going to move on to my second one. And I know that the fact that point U is the midpoint of segment SL, that implied that, well, that was given. That implied that those two segments were congruent, segment SU and segment LU. Again, be careful with your letter ordering. You need to match up corresponding vertices. So those two segments are congruent because it's the midpoint. So we would write definition of midpoint. From there, I need my third fact, because that was my second one. So my third fact about these two triangles that are congruent is that they share segment TU. And those are congruent because of the reflexive property of congruence. Now I'm ready to say that these two triangles are congruent because I have listed out the three facts about these two triangles. So we got triangle TUS is congruent to triangle TUL because, just like I said earlier, side angle side. Now that I've proven these two triangles are congruent, I'm going to use CPCTC. I know which fact to write because it's what I'm trying to prove. It's helping me reach my end goal. Because once again, now that I've proven these triangles are congruent, I know that the other three parts that I knew nothing about originally, I now know that they are congruent. Because if these whole triangles are congruent to each other, then that means that all the parts that make them up are congruent as well. So that means segment TS is congruent to segment TL. It means that angle S is congruent to angle L. But that's not what I'm searching for. That's not going to help me reach my end goal. My end goal is to say that these guys are congruent. So that's what I know. That's how I know to put this here. That these two angles, STU is congruent to LTU. And you are done. On the next one, dealing with this shape here, this quadrilateral, and it tells us that these pairs of opposite sides are parallel. It doesn't say it, but I know now that this quadrilateral is a parallelogram because both pairs of opposite sides are parallel. And so by the definition, I know that this is a parallelogram. So I'm trying to prove that these angles here, this pair of opposite angles, are congruent. So I'm trying to reach to. Well, first off, these sets of parallel lines, this top and bottom, and then the left and right, they don't help. Those two facts don't help us prove that angle P is congruent to angle N, or they don't tell us that. It's because these angles are formed by 4 different lines. So we can't say, hey, if lines are parallel, then these two angles are congruent. Because those two angles are formed by 4 completely different lines. You're only allowed to do that when you have 3 lines involved. 2 parallel lines and 1 transversal. So we're going to have to go a different route. I noticed, though, however, that these 2 angles are corresponding parts in these 2 triangles that are created by the diagonal MO. So if I can somehow prove that those 2 triangles are congruent, then I can use CP/CTC. So I need to find 3 facts about these 2 triangles. I need to find 3 corresponding parts that are congruent. So let's look at what we're given. First off, I'm given that these 2 lines are parallel. That's the left side and the right side. And so if I consider those as my parallel lines and this as my transversal, this diagonal as my transversal, I see that I go from transversal to the line that's parallel, the one that I'm talking about right now. And I do the same thing over here. I start at my transversal and I draw an arc to the line that's parallel. And that's how I can identify the 2 angles that are congruent. I know they're congruent because if lines are parallel, then alternate interior angles are congruent. And this is we've done this many times in the activity. So because these angles are congruent, that's what tells me that angle PMO is congruent to NOM. So that implies that fact. Now let's move on to our other given, and this implies there's a different set of alternate interior angles that are being formed here. So I'm going to do the same thing. I'm going to start at my transversal, and then I'm going to draw an arc to the line that's parallel, the line that I'm currently focusing on, and that is the top and bottom, those 2 lines that are parallel. So start at transversal, draw an arc to that line that's parallel that we're talking about. So that's how I identify these 2 angles that are congruent. Once again, because if lines are parallel, then I can conclude those angles are congruent. And those 2 angles are, we can call this one NMO, and that's congruent to angle POM. So I now have 2 facts about these 2 triangles. So now I need to find a third. Well, we've used our 2 givens, so now we need to rely on the diagram, and hopefully the diagram will show us or tell us that third piece, that third corresponding part that is congruent. And it sure does, because we can see that these 2 triangles share segment MO. And so I know my third piece is segment MO is congruent to segment MO by the reflexive property of congruence. So I now have proven these 2 triangles are congruent, and if they're congruent, then the other corresponding parts have to be congruent as well. And that corresponding parts that I'm looking for is my prove statement. It's what's my goal. It's angle P and angle N. So I've got my game plan. Now I'm just going to write it down in the 2-column proof in this format. So because of this first given, that implied, because this is true, that showed me that these 2 angles were congruent. That angle PMO is congruent to angle NOM. So our first was given. And then like I said, the reason for these angles being congruent is because if lines parallel, then I can conclude that these alternate interior angles are congruent. So now we go on to our next given statement, which is the other set of parallel lines that was given to us. Item 4, because this is true, that implied that these angles were congruent. So it's logically, it makes sense to, once you write that given, immediately after it, write what that implies. And that is that angle NMO is congruent to angle POM, and for the same reasoning, if lines parallel, then alternate interior angles congruent. Sorry for my sloppy handwriting, just trying to go a little bit faster. Now I have my first and second piece of information about these two triangles, so now I need to write my third, and that is that they share segment MO, and I know that segment MO is congruent to itself because of the reflexive property of congruence. So now that I have listed my three corresponding and congruent parts of these two triangles, I'm ready to say that they're congruent. So I'm given that triangle MPO, so MPO, that is congruent to triangle ONM because of angle, side, angle, because I have that angle, that side, and that angle. Right after you prove triangles are congruent, you're going to use CP/CTC. And again, because of the fact that these two triangles are exactly the same size, same shape, there's three things I could say. I could say that segment PM is congruent to segment NO. I could say that segment PO is congruent to NM. But those two are not what I'm searching for. That's not my end goal. My end goal is to prove that angle P is congruent to angle N. So all these statements are justified by CP/CTC, but you need to write the one that is helping you reach your end goal. So those two are congruent. I'm going to keep going with these proofs. We'll come back to those quadrilaterals in a second. Excuse me. Okay, for this one, that's on the last page. It's we've got ourselves a rectangle, and we're trying to prove that segment EL, so that's this diagonal, is congruent to QU, that diagonal. Now it is one of the properties for quadrilaterals that the diagonals are congruent, but this is a proof. This is proving why that is a property of rectangles. And so we can't just start and finish this proof by saying, well, the diagonals are congruent. You're done. No, this is a proof of why that property is always true for any rectangle, no matter what the lengths or the dimensions of the sides. So what we need to do is find two triangles whose these segments are corresponding to one another. And the two triangles we're going to choose is this. I'm going to put it in red ink. I wish I had my other colors. Maybe I can find some other colors. This one, let me fish around for blue. Will do just fine. And then this triangle right here. Now there were other triangles that you could have chosen to prove, but I knew to choose these two because I looked at the proof and I said, okay, well, we're going to use, obviously we're going to use this triangle as one of them, and then I figured out what the other triangle was because of this angle there. So I know that this is a rectangle, and so the definition of a rectangle is a quadrilateral with four right angles. So I know that this is a right angle, and I know that that is a right angle. And because these two angles are right, I know that they are congruent to each other. And so, because all right angles are congruent. And so now I need to find two other facts why these triangles are congruent. I know that in a rectangle, because a rectangle is also a parallelogram, I know that opposite sides are congruent. So I know that segment EQ is congruent to segment UL. And this is just a property of rectangles. And so opposite sides of rectangles congruent. And then I noticed that these two triangles share segment QL. And so we've used this property quite a lot, the reflexive property of congruence. And so now I have my three facts. These two triangles are congruent because of side, angle, side. And then I will use CP/CTC to say that these hypotenuses in the triangles are congruent, which are the diagonals in this rectangle. So item 2, whatever the statement is,